Okay, hi everyone. How did everyone go with Flex Week? Fun Flex Week? No? Busy Flex Week? How did the assignment go? Probably for people sitting in here right now, you probably went okay, and there might be lots of people at home or somewhere sitting there desperately trying to get it finished by 5 p.m. tonight. I'm not sure. But I hope you're all happy with, what you learnt. So the main point was to learn from the assignment. Who feels that they learnt a lot about programming, debugging, 2D arrays, enum structs? Okay. Yeah, we've got quite a high percentage of hands up there. So also for a lot of you, it might have been your first big program that you've written. So, if you didn't finish the whole of stage 4, if you didn't finish the whole of stage 3, whatever you got up to, if you spent a lot of time and you learnt a lot of stuff, that's the main thing. So be proud of yourselves. And if on the other hand you feel like, did anyone feel they should have started it earlier? Yeah. So if there's things that you could do differently next time for assignment 2, try and do those things differently. But, we've all got busy, hectic lives and we all do our best. All right. So yeah, be happy with what you've done and yeah. Live lecture codes up as always. Yeah, so the assignment, as we know, is due today at 5 p.m. Anyone who is still working on it today, keep in mind, there's late penalties. It's 5% per day on the hour, and it's off the maximum mark. So I believe if you crunch the numbers, if you were never going to do stage 4, you can hand it in 2 days late with no penalty. But I don't know. I'm just giving you that information. Hopefully everyone's on top of it and's done and ready to move on. But remember also, because we've got assignment 2 coming up soon, remember to get support from the proper places. Please, if you're somewhere right now doing a last minute panic, please don't be tempted to plagiarize with assignment 1. If you're stressed, just please submit the work you've done. All right, so get support early on in help sessions. We've also got some revision sessions coming up, I think next week. Ask questions on the forum, come to us at the end of lectures, go to your tutors, get that kind of support. Don't be tempted when you're tired and panicked to plagiarize or get yourself into trouble. So yeah, we don't want you to be missing out on programming. We've got assignment 2 releasing on Thursday at 9 a.m. That's all I'll talk about it today. It's going to be based around linked lists though, which you might be thinking, what are they? We haven't done them yet. We're starting them tomorrow, so you'll know about them. And we're doing all of the vital kind of concepts that you need to be able to do in order to do the linked lists. So that's what we're going to finish covering today. So yeah, before Flex Week, we were looking at arrays of strings, command line arguments. We did some revision with 2D arrays to help people get started with the assignment. But then in the last lecture, we started pointers. And pointers are notoriously sort of difficult for people to get their head around at the start. All right, it will take a few attempts before you're really on top of it. Hands up who feels like they're completely on top of pointers at the moment. We do have a few. Hands up who thinks they need a recap. Hands up who's never heard of a pointer. Okay, yeah, there's someone. Okay, if you haven't heard of a pointer, you'll need to go back and watch the second lecture in week 5. And maybe you have heard of a pointer and you're joking, I don't know. Or maybe you haven't had time to watch the lecture because you're so busy on the assignment. That's valid. All right, but we will do a pointer recap today. There's a little bit of pointer stuff we didn't finish. And then we're going to introduce something new, a little bit new. So far, everything that we've been storing in terms of variables has been on the stack. And what do we know happens to our variables if we put them on the stack when our functions end? Yeah?
Like disappear.
They what?
Like disappear, don't store them anymore.
Yeah, they're not there anymore. So if we have local variables in our functions, when that function finishes, that space that they were using gets used by something else, right? And we'll go through that again today. By using the heap, which we'll learn later today, we'll be able to control the life cycle of our variables ourselves when we want to. And that'll allow us to do all sorts of things like return arrays from functions, create memory exactly when we need it, things like that. Then at the end, something a little bit different, we're going to talk about having multiple files in our program. So far we've been packing everything into one file, and we do want you to do that for assignment 1. Don't suddenly go and change assignment 1 and split it up into multiple files. You can't submit it like that. But for assignment 2, we'll be breaking things up into more than one file. So we'll look at that today. And that's not too bad, that's not too hard. Okay, so just a bit of a recap. We've got memory, and when we say memory, we mean like RAM. And when our program's running, there's a whole lot of data that's stored in RAM, right? Our variables are stored in RAM. And we can think of memory as just a giant array of bytes, and every single byte has its own address, sort of like an array index. It's got its own unique address. They're often printed out in hexadecimal. So over here, the OX means hexadecimal. When you see numbers that have letters in them, A, B, C, D, E, F, you're probably looking at hexadecimal. You don't really need to know this, but A means 10, B means 11, etc. F means 15. But we don't have to convert in this subject. So these are numbers. And I've just made up fake addresses. Our addresses in reality have many more digits than this. But for the slide, I just made up short ones. Okay. Now, typically when we're programming, we just say something like int x equals 2, and the system goes and finds, a place to put that value, and it's going to be stored at some address. And a lot of the times, we don't care what that address is.
Attention, attention. This is the UNSW Security Operations Center. We are about to commence emergency exercises in this building. Everyone must participate. Please follow instructions issued by the warning system. Repeat, attention, attention. This is the UNSW Security Operations Center. We are about to commence emergency exercises in this building. Everyone must participate. Please follow instructions issued by this warning system. Thank you.
I guess we're having a break. We don't know what soon means. Hello? Is that on? Yeah, okay. All right, let's try this again before we get evacuated. We'll see where we can get to. Is it on? We're back on. Okay, all right. If we want to get this address and find out what it is in our program, we use this ampersand, which means get the address of, which hopefully you've all remembered typing in before in scanf. If we're just printing x itself, the contents of x is an integer, which is 2. If we're trying to get the address, we've got to print it out with %p. Now, usually we don't really care about printing out the addresses of variables, but we do it maybe in debugging or trying to understand what's happening. Okay, so every variable has an address. And we don't know where they're going to be beforehand. And even if we run our program again, the exact same program, things won't be at the same addresses. All right. Now, we've seen this before with scanf. We give scanf the address of our variable, so scanf can go, when it reads in whatever the user types in, it can go to that address and put the value there. All right, it's sort of, like I said before, it's like you give the address to the pizza shop so it can deliver the pizza to you. Scanf is like delivering that 99 to that address you give it. So we've been using it all the time. Now, to actually store these addresses in a variable, that's where we need to use a pointer. So pointers are just variables that can store addresses. Here, the name of the pointer is number PTR, or number pointer. This star turns it into a pointer variable rather than just an int, right? And we have different types of pointers. So different pointers are allowed to store addresses of different types of variables. So if you want to store the address of a double variable, you've got to store it in a double pointer, etc. Okay, so that's all pointers are, a variable to store addresses. And we do that kind of thing in real life. We store addresses or contacts in places. So when we need that address, we've got it stored somewhere. Now, in this scenario, I've got some fake memory addresses I've made up, but we've just got some normal int variables. I've got x, which is equal to 7, y, which is equal to 99. And they, of course, are living at some address. And then I've got a variable called x pointer. Again, it's also just a variable. It's living at some address. But the value that we're storing in this pointer, in this example, is the address of x. And in this example, I'm just pretending that this would be the address of x here. And that's what I'm storing in this variable. And we think of this variable as pointing to this one, right? It knows where it lives. Is everybody happy up to here? Yep?
What's the difference between just setting the pointer to 7 and just setting x to 7?
If we try and just say, like, this equals 7, is this what you mean?
I'm referring to the last line. The pointer.
Ah, right. Yeah. So when we get to this next line, what we're doing is we're dereferencing the pointer. So x pointer refers to this sort of chunk of memory. That chunk of memory is storing an address. When we say star x pointer, we're going to that address. And in this case, we're storing the value 7 in there. And like, what's her name? Mandy has just said, what's the difference between doing this and saying x equals 7? In this situation, yeah, nothing. They serve the same identical purpose. They're setting this value to 7. But it shows us two different ways we can do it. Directly by just setting x like we normally do, or indirectly via a pointer. And this is important because we can pass pointers into functions, and then our functions will know the addresses of our variables and they can go and change them. So that's why we would sometimes want to do it. In this context, yeah, you could just say x equals 7. But this is the syntax. So again, this is just to get your head around the syntax. Oh, we give up then. We give up.